I'm in trouble.
Yeah.
Okay, we already talked about parametric equations, but let me just get this. Who is in 6th hour physics?
Everyone else. Yep.
And Alex has which hour?
Third.
Third. Okay, thank you. All right. Parametric equations. You remember these, hopefully, a little bit from pre-calculus. Okay. When we want to describe motion on a curve, it is best to use parametric equations. Okay. Basically, we have two equations. We have an x and a y equation, both in terms of a third variable t. T is what is called our parameter. That's why they are called parametric equations. What's nice about parametric equations is that they have direction because they're describing motion. So if you recall, and when we go to graph these here soon, you're going to have arrows pointing you in the direction that the curve is going. Okay, so just to kind of give you an idea of where this is going, do you remember last year when we talked about position, velocity, and acceleration?
Oh, yeah.
Okay, but it was really only something moving back and forth or something moving up and down, right? It had to be linear motion. Okay?
Yeah, we like that.
Eventually, we're going to be able to do all of that, but moving multi-direction.
Interesting.
Okay.
There we go.
Okay. So, that is where we're going. This is where we have to begin. All right? So there are two different ways we can think about graphing a parametric curve. The first one is by creating a table. So please write down this set of parametric equations. X equals t squared minus 1 and y equals 2t.
What? Nothing. I just did it.
I know. You make me nervous when you giggle. For no reason.
We're making kind of wolf.
Currently?
Yeah. That's my real passion. The only you're looking for. Please follow. No. Cool. There's a target. Press the shoot it. Ooh.
You can get through the notes. I'll let you shoot it at this. And if you hit that middle, I'll give you a driving.
Oh.
That's a challenge.
Or a granola.
How about one practice round?
I don't like that interest, but I think you can.
Can we each try?
Oh, that's a.
Sure.
Yeah.
We have enough time. We can get through.
You guys gotta
Okay.
go first, though.
Wait, maybe that should be our 8-person project. Like, make just a big.
Get the whole bag.
Calculus and physics.
Okay.
That would actually be really cool if you made a catapult.
Like a full-size catapult.
Okay. So we have an idea.
Yeah.
Let me just digest it a little bit. Okay, so on an unrelated note, we watched, my husband and I got to go to the U.S. Olympic trials of curling last night.
Fun stuff.
Oh, my
Right?
sister worked there.
Really?
Yeah.
I did not see that. It is a very interesting sport. Have you ever watched curling?
Yeah.
Pushing the ground.
And they get intense. I don't know how somebody
You know
can
it's
stand.
That's
That's all I know.
Okay, so the I guess the non-thoughtful way of creating a graph is just to make a table of values. I say non-thoughtful because it's really just plugging and chugging. There's not a whole lot of strategy involved to it. Okay, but instead of making an X, Y table, you would make a T, X, Y table. Hello. Look, do you want this something here for now? Sure, why not? Back in the corner. Okay, so this is giving us that T is going from -1 to 4. All right, so if we plug in T is -1, what do we get for X?
0.
And what do we get for Y?
-2.
Do you agree with Jake?
Still running down the chart.
Oh my god.
0.
0 we get.
I agree. -1 and
0.
Yay.
Grayson agrees with himself. Awesome.
I have a cart upstairs.
So do we need this one still?
I don't think so.
Okay.
I'll bring that one down tomorrow.
Okay.
All the stuff that's in your cabinet.
Okay. Sounds good.
And then punch and everything will be in the fridge.
Awesome. Okay, what do we get for T is 1?
0.
2.
T is 2?
3, 4.
8, 6. 59.
Okay. So when we go to create this graph, oh man.
Whoa.
Okay. We create this graph based on our t values, and we go from the smallest t to the largest t. This is when t was -1, this is when t is 4, and so the direction of our curve would be that. You don't have the arrows, it's not a parametric equation. Okay. Now, is that the most efficient way to graph? Okay. Here come your brains. My 3-year-old thinks his eyebrows are his brains. We cannot convince him where his brains really are. X equals radical t, y equals t. Okay, this is actually pretty easy. The second way we can graph is to actually convert into a single equation. And whether we are going to graph this or not, this is a skill you need to be able to do. Okay? Now, I actually don't need this t is greater than or equal to 0. You should know that already. Why? Okay, we cannot have negatives under the radical. Now, since y equals t, we can plug y in for t. You can have y equals radical y, or you could have x squared equals y, if you so choose. However, what would be the domain of y equals x squared?
0 to infinity.
How do you know that?
As I said, so.
Okay, how does Jake know that?
Because of the other way. You just can't do it the other way. X equals radical y doesn't work out.
Okay, so you can think of it a couple different ways. X equals radical y, that's only going to produce positive x values.
Wait, isn't the range? No.
Okay.
You can only get positives.
In both ways, we can only get positives. Okay. Up here, x is radical t. X can only be positive numbers, so when we smush them together, and when we eliminate the parameter, x can still only be positive numbers. Okay. So we have to consider the domain of t up here when we want to think about the domain of the actual curve. Okay. So what we have, y equals x squared, it looks like this, but we only have it on the positive side. Do you remember how to graph parametric equations in your calculator?
No.
Get your calculator out. Okay, so if you go to mode, we need to be in
4. That's a gold.
parametric mode. If you are in parametric mode, when you go to y equals, you have x and y.
Yeah.
Okay? If you press the X button, it'll actually appear as a T because we are in parametric mode. Okay? So we want t squared minus 1 for X, and we want 2t for Y. Okay? Now, this is not the graph that we created. Okay? It's only a portion of it. Does anybody else's look like mine?
Yeah.
Okay? Technically, this should be a full parabola, right?
Yeah.
If we go to window, we'll see that our T min is 0 and our T max is 2 pi. Okay? So we can change that. If we wanted this right here, we can change T min to -1 and T max to 4. And then it would graph the portion that we graphed right here on the board.
So we just have to set the domain of our thing to that.
Right. Yours will default for 0 to 2 pi. And I think if you go ahead and go back to window, go ahead and change it back to 0 to 2 pi. And then you can change it according to whatever you need to if you have the graph.
What do we have to change it to?
That's too high.
Well, its default is 0 to 2 pi.
Yeah.
I changed it from -1 to 4 so I would get this graph that we had on the board. But then I changed it back to the default just so the next time it'll be there. You should always be in radians unless you are finding an angle using sine, cosine, or tangent.
Oh, don't do that. It's gonna not change.
Are you in stats?
Wait, I changed the T step.
Yeah, T-step needs to stay as,
It's not a function.
okay, yes.
What were we supposed to do?
Did you change a bunch of stuff you weren't supposed to?
Is that what you're reading?
Yes.
I'm gonna assume the bullseye. I was like, that's kind of worried.
I feel like parametric and polar equations are a pretty essential part of the thing.
I don't know why mine isn't stuck.
Then you had to have experiment.
Yeah. I probably
I just,
just know.
it makes sense that it was in pre
No, it's because I didn't.
Why?
It's not the right check it out.
Very much.
From like 0.1 to.
Who was your pre-calc teacher?
Okay, we're gonna- That's your, what's your
You're gonna be
two
very
steps?
disappointed.
Uh,
All right, please write this one down. Okay? When we eliminate the parameter, we are typically going to solve for t in one equation and plug it in for t in the other so that we can get an equation in terms of x and y. However, if trig is involved, that is not always going to be the best way to do it. And so we may need to rely on our trig idea to help us. They always come back. So here's the deal. If we try to solve for t in the x equation, we would add 1, divide by 4, and what? You want the inverse cosine of all of that mess equals t?
Yes.
I don't think so. Okay, let's do the same thing with the other one. We could subtract 2 and divide by 5 for the sine of t. Why would we square everything? But you do have the right idea.
So that your cosine is going.
We know that cosine squared plus sine squared equals, so x plus 1 the quantity squared over 16 plus y minus 2 the quantity squared over 25 equals 1. Now we have an equation we can work with. What is that? It's an ellipse.
Do that, and they were all almost the same.
I used one of those in
Yeah,
my,
they were actually really close.
Yeah?
Except one was 15 on the bottom,
Yeah.
and then it was,
Where's the center?
it is
negative 1, 2.
Okay. Since 4 squared is under the x, we're gonna go 4 horizontally from the center. And since 5 squared is underneath the y, we're gonna go 5 vertically from the center. And if this is a parametric equation, what do we need? Arrows. We have to determine which direction this is going. So, we can't always assume clockwise. If we plug in 0, because our domain is 0 to 2 pi. If we plug in 0, x would be 4 cosine of 0 minus 1. 3. 5 sine of 0 plus 2. Okay, so the coordinate 3, 2. This is where we are at t equals 0. What would you like to plug in next?
1.
You want to plug in 1?
Plug in 2. Negative 2. No 2.
Pi over 2 would be excellent. When we plug in pi over 2, we have 4 times 0 minus 1 and 5 times 1 plus 2. Negative 1, 7. So this is where we are when t equals pi over 2. So our arrows would go in this direction. Counterclockwise.
It's a lie.
What's a lie? All right, you want to learn something new? This is new?
Oh, yeah.
This is pretty new.
Yeah.
Is this not new?
No.
I was questioning what a calculus
No,
is.
this is new.
we've never learned about this.
I was your pre-calculus teacher. I wasn't?
No.
Oh.
Oh.
remember doing it, but
I did.
Did I have any of you in pre-cal?
None of us learned this.
Yeah, none of us did.
I remember it, but I don't remember
Hey,
how to
Isaac, who
do
did you have?
I know for sure that you all did a problem like this because it was a bonus on your test.
Yeah.
Which means we would, I know, I teach the same examples. I know you did a problem like this. And I know you had at least 3 homework problems that were like this. And it was a bonus on your test.
3 homework problems.
Now,
2 years ago.
okay, you don't remember it. Fine. Does it make sense?
Sure.
We'll take it.
Great.
Do matrices ever come back?
Not in this class.
Oh.
If you were to take linear algebra, then yes, they would.
Linear algebra sounds like an easy class, but I know it's really hard.
It does.
It's linear algebra, we're just making lines.
Okay, so those of you, okay. So you 8 who claim you don't remember this, which is fine. I'm fine with you not remembering. But something that we've learned before that we forgot, we need to be able to pick up. So if I gave you a problem like this in your homework, are you going to be able to do it?
I'll
I
do
guess.
it.
It kind of looks like a potato.
Yeah.
Calculus students are good at
Complicated.
potatoes.
Potato problem.
Please just read this
Smooth curve and curve.
to yourself.
That's supposed to be accept.
Where?
Apparently they like expect.
Accept. But expect to accept.
I'm just gonna wait for it to dumb it down.
Okay, so here's the deal. You need to be able to read something and try to understand what it means. So,
We layman's terms.
I is an interval. Don't be super worried about I right now. Okay? Basically, what is it saying? What does it mean if f prime and g prime are both 0?
F prime, what prime?
G prime. It's not smooth.
Critical points.
Okay. So we have a parametric curve. If you take dx dt and dy dt and they are both 0, then we have a non-smooth curve. Okay? Anytime both of those derivatives are 0, it is not smooth. That's what you need to know. So I would write down your parametric functions, x equals f of t, y equals g of t. If those derivatives are both 0 at the same time, we don't have a smooth curve. What the last part is saying is that it can be piecewise smooth. So between 0 and 1 it's smooth. Between 1 and 2 it's smooth. But it's not smooth at 1. You okay?
Yep.
Trying to make sure you weren't like having a medical emergency.
Nope.
Okay?
You cannot.
Cannot wait. Is that canon joke?
Um,
No, I'm not.
Canyon Walk.
Yeah.
Right?
Oh, I gotta take these out, don't I?
Yep. So when we make it. Supposed to make that weird, so make it, we make it.
Okay, so we are going to look at a curve called a cycloid. I will show you what it looks like when we are done determining if it is smooth. But we are going to look at what's called a cycloid.
Cyclone. Is it,
Oh,
is it
no,
that
that's
cone
it,
thing
that's
that's in
it.
there? Oh wait, that's something else.
Those are my tonic sections.
Tonic section. Oh, it's supposed to be good.
Here's our cycloid. X equals 2 theta, 2 times the quantity theta minus sine theta. Y equals 2 times the quantity 1 minus cosine theta.
Cycloid and eccentric.
Cycloid also reminds me of cyclops.
Yeah.
More.
Which, by the way, K-State plays the Cyclones this weekend.
Oh, that's a.
I'm missing, yep, I'm missing my yearly Colson trash talk.
I always say something out.
Does it make you kind of happy to see them be successful?
I am happy for Colson.
Us too.
After all the bad years he's gone through.
All right, derivative of x. Okay, now, let's hold up real quick. Oh my gosh, there's a theta. It is okay to have theta as a variable in the parametric equations. Oftentimes you will see t, but sometimes when there's trig involved, you'll see theta, which is like the T in Greek alphabet, right?
Yeah.
So it's still like, okay.
Don't worry about it.
All right. So derivative.
-2 cosine theta.
How about 2 minus 2 cosine theta?
What do you think of derivative?
Do not call him names, no matter how you feel about him. And y prime. 2 plus 2.
Would just be 2 sine.
Oh, that is a 1. I'm sorry. That is a 1. That is a 1. You're right. You're right.
That's what you said it wrong.
Okay. All right. So let's look at when these are both 0. If we set x prime equal to 0, we are essentially looking at where the cosine is equal to 1. Would you agree?
Yeah. That's a 0.
And
Pi.
try again.
2 pi.
All of the even pi's. Would you agree?
Yes.
Okay. If we want to look at where y prime is 0, we are essentially looking at where the sine is 0, which happens where? 0. Pi,
Oh, it's not sine.
2 pi, 3 pi, 4 pi, etc. Okay. So, is this a smooth curve?
No, it's not.
It is not smooth because there are places where both x prime and y prime are 0.
Yep.
So this curve is not smooth when theta is 2 pi n, because those are all the places that x prime and y prime are simultaneously 0.
It's piecewise smooth though.
It is piecewise smooth, so it's smooth between 0 and 2 pi. It is smooth between 2 pi and 4 pi. You are right. Would you like to know what this looks like?
It's gonna be on the test.
It just keeps.
Well,
Is that a sine and a cosine on top of each other? You're just not including the negative y's?
Not sure what that value is.
Is that what the graph is though?
This is what the graph looks like, yeah. I don't know the specific values. I don't know if I have that.
Did you get that graph from drawing?
Oh, we do too know what that value is. What is that value?
0.
Well, this is 0. What's this value?
2 pi.
2 pi, because we're not smooth there.
4 pi.
4 pi.
6 pi.
We're not smooth there.
So it is, it's a sine and a cosine. On top of
Sine and
each other.
cosine take an entire 2 pi to draw the whole thing.
Was it 2 sine? No, no.